Yes. Hello everyone and welcome to the presentation on two fundamental data structures, the queues and the linked list. My name is Lakhan Singh and today we will explore what these data structures are, their different types and what they are and how they are used in the real world, and most importantly how we can implement them using the C programming language. So let us start with the queues. The best way to understand a queue is to think of a line of people waiting for a ticket. Suppose this is the line of people. This is the first person. This is the first person. This is the second. This is the third. This is the fourth, and this is the fifth. Now, who do you think will get the ticket first? One who is in the first position of the line. So this is what a queue is. The best way to understand a queue is to think of a line of people waiting for a ticket. The person who comes first gets the ticket first and leaves the line. The new person always joins at the back. This is the back first, and just to mention, the first position is called the front, and the last position is called the rear. This is the queue terminology. Now this is exactly how a queue data structure works. It follows a FIFO structure. What is it? A FIFO. First in, first out. While on the other hand, a stack data structure uses a LIFO concept, last in, first out. Okay. So now let us move to some of its key features. It is a linear data structure. As you can see, it is an ordered collection of data. It has two ends, front end and rear. Okay, so now let us move on to the basic queue operations. The first one is called enqueue. Now when we add an element into the queue, we always add it from the last position, which is called the rear. So we will add an element, insert an element at this position, and suppose it is already filled, then we will create another space and add element here. The second operation is called dequeue, which is when we remove an element from the queue. Now, which is from which position do we remove a queue? We remove a queue from its first position, index 0. Now there are more features or more operations that we can apply or create. The is first one is called is empty, which we use to check whether the queue is empty or not. Is so to check whether the queue is full. Once it is full, it we cannot apply enqueue operation, and if the queue is empty, we cannot apply the dequeue function. And peak returns the value which is, if we apply a dequeue operation, then which value will be removed from the position. So this is called the peak. Peak always returns the first element in the queue. Now let us study about some queue applications. The first one is CPU scheduling in operating system. The second one is called printer spooling. Now what is the printer spooling? Suppose we have a printer and we want to print 10 files. So we give all those 10 files to the printer, and it will print them one by one in the order how it received them. The web server request. So suppose we have a website and it is connected to a web server. Suppose there are 100 people who are using that website, and they all make 100 requests. The web server receives those requests and responds accordingly. So in what order does it respond? It responds within the order of queue. The first, it operates the first request, then sequentially. Now let us move to how now. Okay, so now let's study how we implement a queue data structure in the C language. So let it be. Okay, now let's see. So first of all, we will create a main function, and we have called an enqueue operation, and we have asked the we have so suppose we are creating a program in which we are going to add 10 value in a queue. Oh, how do we do that? First of all, let's go to the enqueue function. Okay, so this is the enqueue function. Now first of all, we will check whether the queue is empty or not. If it is empty, then okay, sorry, we do not check whether the queue is empty. We check whether the queue is full. How do we check it? We check the rear position. Rear holds the index of the final. Rear holds the index of the final index of the of the queue, and if it is equal to the size of the size minus 1 is equal to size of the array from which we have implemented this queue, then we cannot add more. So if we check if it is equal to the size, then we print queue overflow. Otherwise we check whether the front is minus 1. What do we mean by when the front is minus 1? When the front is minus 1 means, let me explain you. So suppose it means that we don't have a queue, so we create the first element and we point both the front and the rear to the same element. That is what the front is. Then we increase the queue values, and let me change the color. Then we change the queue value, then printf. Similarly, what we do when we decode the operation, we check whether the queue is empty. If it is empty, then we do not perform any operation. Otherwise, we check. Otherwise, we increase the value of front, because we are going to see the how do we remove that. Suppose we have this queue here. Suppose we have this queue here, and this was the front. Now we dequeue. Now we move the front to here. Now we will start our array from this front. This becomes our first element, which will be dequeued if we perform the dequeue operation again. Okay, so this was all of it in queues. Now let us go to linked list. Okay. So now let's move on to linked list. A linked list is a linear data structure, but is a very different from an array. Instead of storing elements in contiguous memory allocation, what it does is it links the nodes. What is a node? A node is a structure, like in C language it is a structure which holds two values. The first one is data, which is any kind of data that you are going to store in the node, and the second one is a next pointer. Now what is the next pointer? Next is going to store the address of the next node of it. So if suppose we have this memory, we create this a node, and this is going to store the next node. Suppose we have another node, so the address of this position will be stored in the next of the previous node. This is how we link all these nodes, and the final node will link, and the final node's next is going to represent is going to show null. It is because there is no next address for it to store. Now let us study some differences of linked list and arrays. These are the two advantages, and these are the two disadvantages. The first advantage of a linked list over array is it is of dynamic size, that we can change its size whenever we want, and it is an efficient insert and delete. The first disadvantage is more memory overhead, because for storing one data we are using twice the storage. We are storing the address of a variable also, and we can traverse sequentially only. So if we want to reach here, we cannot directly come to if we want to reach here, we cannot directly move here. What we are going to do is, we have to first, this is called the head. First we will point to head, then we will move to from next to next until we reach the required element, if we want to create any change or if you want to perform any kind of operation on it. Okay, now let us move to its types. The first type is of singly linked list, and the second type is of doubly linked list. Then the third is circular linked list. Singly linked list is what we did now. And what do I mean by doubly linked list? So if its node stores three values. The first one is data, the second one is next, which is going to store the address of the next node, and the third one is previous, which is going to store the address of the previous node. So we cannot just move in one direction, we can move in both the direction. What is circular linked list? Circular linked list last element do not point to null. Instead, it points back to the first element, first node, which is head. Now let us see some of its application. The first one is music playlist, second one is image viewer, and the third one is browser history. So in the end, let's just see the algorithm on how do we implement a single linked list. The first thing is we'll create a structure, and in that structure we are going to store two values. The first one is int data, and the second one is node star next, as it is going to store the address of the next node. How do we operate on it? So first, so we create certain functions, and that functions we send head pointer to pointer, through which we are going to access the first element, and with that element we will traverse with the help of a temp node, which also stores the address. And at first it is going to store the address of head, then it will move one by one based on the next value. Okay, so let us look at the algorithm. Start, initialize head is equal to null. Initially, if we don't have any element in the linked list, head is going to point to null. Insert at beginning, create a new node temp. Yes, temp data value. Now what we are going to do is we are going to insert a data, we are going to put a value that we want to put in a linked list in the data variable of temp, which is our node, and the next one is going to head to null. Well, it should not be null, it should be null, sorry, it should not be head, it should be null. Now insert at end. Now create a new node temp data value, temp next null. If head is equal to null, head temp, else set ptr is equal to head, while ptr's next is not equal to null, move ptr. Okay, so what we are going to do here is, first suppose we have this linked list. So what we are going to do is, first of all we are going to create a node and store this value. Now we are going to create a temporary node which is going to point to head. Now we will traverse from next to next. Once we reach a next which is pointing to null, we will going to insert this address into its next. Now what happened is, now it is officially or I can say permanently or dynamically inserted into this part. And if we want to remove suppose this element, what we are going to do is we are going to reach its next which is pointing to this address, and we are going to put it null. This is how we delete it. How do we display it? Again, we create a temporary node. First we will assign its value like to head, then we will move one by one until it reaches the null, until it reaches the next whose value is null. Okay, so this was it. I hope we have understood the basic concepts of queues and linked list. Thank you everyone.